Hey, have you heard the news? There is a new definition proposal for microbiome in town. Even if you think you heard enough about it, it is really hard to give all the answers in one shot. When we say microbiota, we refer to the assemblage of microorganisms present in a defined environment, such as the human body or individual body sites. So far, so good. Some logic questions may arise. Do we have to be careful with it? Could it be damaged by our lifestyle? And also, do we need to worry about cosmetics that we put on our skin? Will we get in trouble if we use a certain preservative? First, let's take a deep breath. Nobody will get in trouble for a cosmetic product if well formulated and well protected from spoilage, which are two cornerstones of the cosmetic market. Could preservative systems act not only on pathogenic microorganisms but also on our commensal healthy skin bacteria? We could expect that substances with antimicrobial activity like preservatives may impact on the commensal microorganisms on our skin simply because of their nature. Nevertheless, they are used in a cosmetic formula in very low percentages, so the extent of their impact remains questionable. We performed a metagenomic study including one of the most used cosmetic preservatives and one of our preservative systems, both at 1% in a base cream, with the aim of assess the composition of the skin microbiota before and after using a cosmetic product. Using metagenomic analysis of the 16S rRNA gene, we were able to determine the microbiome variation over 1 week, comparing results for skins that did not have contacts with preservatives and skins that did. In particular, cream A and cream C were unpreserved. Cream B contained 2-phenoxyethanol, and cream D our preservative system based on the synergic activity of caprylyl glycol, ethylhexylglycerin, and oxymen 5-O. As you can see from the picture, the microbiome variation over 1 week was similar between cream A, unpreserved, and cream B, protected by 1% of 2-phenoxyethanol. A small variation of genome during 1 week is physiological. As we said earlier, it depends on several life habits. Looking at results for cream D containing 1% of the full-spectrum preservative system, the same observation comes to mind. Although tested on 2 different groups of volunteers, the microbiome variation between formula B and D is similar. Let's now look at another parameter, the Shannon index. It indicates the overall biodiversity within a given sample. This will help us to better understand if, with and without applying preservatives on our skin, we have more or less the same species of bacteria. Comparing Shannon index for cream A and B and cream C and D, we stated that overall the same species are represented between the sample of skin treated with the cream without preservatives and with the cream containing 1% Bioscontrol element pH or 1% Bioscontrol synergy ice. So how is it possible that preservation systems are effective in protecting cosmetic products but seems to be well tolerated by our microbiota? A possible explanation is that in our skin microbial community, all strains cooperate together to find the perfect balance. On the other hand, when pathogenic microorganisms try to contaminate a formula, they act on their own. Moreover, as mentioned before, our ecosystem is constantly exposed to agents that could have an impact on its eubiosis, so we could think that it is a daily exercise for our microorganisms to restore their balance and resist these perturbations. As personal care players, we like to think that we are doing our part in trying to answer some of the greatest questions about this topic. This study suggests that the metagenomic line between preservatives and skin microbiota is very thin, but with so many variables to be included in the final equation. Still, it is not impossible to keep the balance and walk it until we reach the end.